Okay, we have one type of problem left to cover, which is number 5, which is mostly just kind of distributive property, combining like terms. The only difference is the questions are written out in function notation. For example, one of the questions is more or less find f of x, and let's say plus h of x. Okay. What this means is you take the f of x function, and you take the h of x function, and you add them. You add f of x, so x squared plus 3, and it's appropriate to write that in parentheses, at least as the first step. And then we're going to add the h of x function, and it's appropriate to write that in parentheses as well. You can skip the parentheses for addition problems, but for subtraction problems, you have to use parentheses, so let's go ahead and use them for addition also. We have, the reason I say we can skip it for addition is, remember, if you're adding terms in parentheses, if it's addition, you can just drop the parentheses. So that's what I mean by we could have skipped the parentheses, but technically we should write them. Yeah. So we're just going to add all this together by combining like terms. For example, there's a squared term and a squared term. There's only one linear term, and then there's two constant terms, or what are called degree 0 terms. So let's just add them together. X squared plus 3x squared is 4x squared. There is no other term with just x, so we keep our 5x term. And then 3 minus 1 is 2. All right. And so that is the f of x plus h of x function. I'm going to erase this in a second, so if there's anything you'd like to pause, go ahead and pause now. But I'm going to use the same screen for the next two questions. All right. Okay, I think we also need to do subtraction, and I believe the homework has 3 problems included subtraction. So let's call this problem B, and we'll say that it's f of x plus g of x minus h of x. So once again, now we've got 3 total functions we're going to use. F of x means we write out x squared plus 3. And we use parentheses. Plus g of x means we say plus 4 minus x squared. And we keep that in parentheses. And then minus h of x. So this is why the parentheses are so important. When you have subtraction, you cannot skip writing out the parentheses. And I'll show you why in just a second. Okay. Here we have this plus this, so it's perfectly okay to just drop the parentheses. But here, what we have to do is what's called distributing the negative before we drop the parentheses. It's like having a silent negative 1 here. We need to multiply by negative 1, multiply by negative 1, and multiply by negative 1. All that's going to do is change the signs. So instead of having a 3x squared, we're going to have minus 3x squared. Instead of having plus 5x, we're going to distribute that negative. It's going to change it to minus 5x. And then our last term was negative, so we have negative, negative, and so that's going to be plus 1. All right, let's just identify our like terms. For example, we have a squared, and a squared, so those can be combined. We have still just one term that uses x, just a single x. And then we have a bunch of constant values or degree 0 terms. So I use a little kind of sideways 0 here. Let's go ahead and combine them. We have x squared minus 3x squared. So that's 1 minus 3. That ends up being minus 3. We have minus 5x as our only linear term. And then we have a plus 3, a plus a 4, and then a plus a 1. So we have plus 8. and we are simplified. That is f of x plus g of x minus h of x. So write out all three functions, f function plus g function minus h function. And it's very important to write a function in parentheses if you have subtraction, so that you can properly distribute that negative. I would hit pause if there's anything you want to pause on, because I'm going to erase this and then do the last one, which is multiplication. Okay. Now we're going to multiply also, and so this is once again distributive property. It's just that it's kind of a lot of distributive property. So let's do f of x times g of x times h of x. Oops. It's not necessary to use these parentheses. All right. So once again, we're just going to write out f, we're going to write out g, and we're going to write out h. The only difference is we aren't adding the functions, we're multiplying them. So we have x squared plus 3 times 4 minus x squared times 3x squared plus 5x minus 1. So if, let's just do this. Do a little trick. We're going to take this whole expression and cover it up. We'll save it for later. Let's look at what's left. This is just a distributive property problem where everybody needs to be kind of introduced or multiplied. X squared needs to be multiplied by 4 and negative x squared, and 3 needs to be multiplied by 4 and negative x squared. So let's do that. We have x squared times 4, which is 4x squared. We have x squared times negative x squared, which is negative x to the 4th. Remember, when multiplying terms with exponents, you add the exponents. And then we also have a positive times a negative so that it's negative. 2 plus 2 is 4. That's where that exponent comes from. We need to distribute the 3, so we have 3 times 4 is 12. And 3 times negative 3x squared is negative 3x squared. All right. We have a little bit of terms we can combine. We can combine 4x squared and negative 3x squared. And I think that's it. So our final result here is x squared minus x to the 4th plus 12. Okay. Do you remember that function that we covered up in red? This guy right here? Okay. He is still waiting. We still need to multiply by that. So now we have this term, or these 3 terms, which is the result of multiplying this, and we still have to multiply by 3x squared plus 5x minus 1. This part has just been waiting for us until we finish the kind of mini problem on the left. Bunch of distributive property, bunch of introductions to make. For example, x squared needs to be distributed to this term, and this term, and this term. X to the 4th needs to be distributed to this term, and this term, and this term. And then also 12 needs to be distributed to all 3 terms. So all 3 of these need to be distributed to all 3 of these. It's a lot of multiplication. Let's just go ahead and do it. X squared times 3x squared. So you multiply the numbers. This is 1 times 3 is 3. X squared times x squared is x to the 4th because you add the exponents. All right, let's distribute x squared to 5x. 1 times 5 is 5. And then x squared times x, remember that's a silent 1 for the exponent, so 2 plus 1 is 5x cubed. X squared to negative 1, that's just negative x squared, so that's pretty easy. All right, we have to distribute x to the 4th, and in fact, we got to distribute negative x to the 4th. So we have a negative times a positive, so that's going to be negative 3. Then x to the 4th times x squared is x to the 6th. We have a negative times a positive, so that's a negative, negative 5. And then x to the 4th, x to the 1st, when you multiply those, that adds up to an exponent of 5. Because when you multiply bases, common bases, which is an x, you add the exponents. And then lastly, we have a negative times a negative. So this is still going to be, that's going to be positive. And this is just x to the fourth. So x to the fourth. All right, and then we have still 12. 12 times 3x squared is 36x squared. 12 times 5x is plus 60x. Oop, running out of room. And then 12 times negative 1 is minus 12. Let's see if there's any common factors. I'm sorry, any like terms that we can combine. Start with our biggest exponent. This is our only exponent with a 6. So we know our result is going to begin minus 3x to the 6th. Let's look for that 5. This is the only term that's degree 5. So we know we're going to have minus 5x to the 5th. Let's go ahead and kind of cross those out so we can keep track. We're done with this one. We're done with this one. Let's look for those degree 4s. We have a 3x to the 4th, and we have an x to the 4th. We add those together, and we'll get 4x to the 4th. Done with those. Let's do 3, 5x cubed, and seems like the only one, so plus 5x cubed. Let's get rid of those. X squared, we have a negative x squared and a positive 36x squared. That ends up being minus 35x squared. So let's get rid of those. And then plus 60x and minus 12 are the only terms left, and they can't be combined. So let's just write that out in one step. Plus 60x minus 12. Oh my goodness. Oh my gosh, golly. Wow. All right. So anytime you have to multiply 3 functions together, it's not that any one step is hard. It's just distributing and combining like terms. It's just that there's a ton of terms to distribute, a ton of like terms to combine. But we got it. We did it. It happened. All right. Good luck with that one.